Hello everybody, we welcome you to the Multi-Medix webinar series on ultrasound probe testing. This is the second webinar in our series, and today we're going to show you how to replicate first call results without the need for a first call and introduce you to the Multi-Medix ultrasound probe test tool as well. As with our previous webinar, we're going to do a short 2-minute introduction and then there'll be 20 minutes information sharing. We're actually going to show you how to replicate those first call results, and then that'll leave 10 minutes at the end for any questions. So this bite-sized webinar will actually finish within the 30 minutes. For those of you watching this live, you'll be able to write your questions in the chat panel at the end of the webinar in the final 10 minutes. The chat panel you'll be able to see at the bottom of your Zoom screen, it's a little speech bubble icon. Please be aware that this webinar is being recorded, and if you would prefer not to be recorded and your comments not to be recorded, then you can simply leave the webinar now and watch the recording of it, which will be available on our Multi-Medix online knowledge portal from tomorrow. Should you have any difficulty seeing or hearing the webinar at any point, please just type a message in the chat panel and I will endeavour to help you. And please keep your cameras switched off throughout, as this will prevent any lagging issues there may be with the webinar. My name is Marilla Stevenson and I work for Multi-Medix along with the two other people you see on the screen, Jen Reiner and Darren Woolley. Let me introduce Jen to you first. Jen Reiner is our US Sales Director and she's worked in the industry since 2005, and she may well be a familiar face to some of you. You may know her from her time at Trisonics, a leading independent ultrasound service company based on the East Coast of the States. She was in a senior position at Trisonics for about 15 years, and we're really proud to have her on board now as Sales Director for Multi-Medix. So I'm going to say goodbye to you now, but I'm going to stay in the background should you have any issues at all. But I'm going to hand over to Jen now, who's going to introduce Darren Woolley and start off our webinar.
Thank you, Marilla. As Marilla stated, I'll be your direct contact in the US for all your probe repair and probe sale needs. I will send a post-webinar email follow-up so everybody will have my direct contact information. And please feel free to send me requests or questions at any time. I will always be available to answer anything that you may have. I work alongside Darren Woolley, who is our technical director. Darren has 25 years in the ultrasound industry. He is a biomed and electronics engineer by trade, and he has also written several papers on the subject matter. Darren has also implemented our ISO 13485 accreditation at our facility. I'll be back at the end for the Q&A with Darren, but for now I'm going to turn it over to Darren.
Thank you, Jen.
Thank you.
Hello, everybody. Thank you for this opportunity to run through how we can test linear and curvilinear probes quickly and easily with nothing more than a short protocol, optimizing the system settings and the use of a specialist little test tool, as we have here. This allows us to effectively replicate the findings of a first call report, which will be able to tell us how we've got element performance going on, which is essential to our clinical end users for getting good images. I've got an ultrasound machine next to me, so I'm just going to switch my camera so you can see an ultrasound console, and I'm going to demonstrate how we test the probe and how we optimize the machine. So just here I have a Philips 650. So representative of a typical console, and we have a linear probe. And what we're going to do is just run through how we optimize the settings and check our transducer. The first thing we always do as a matter of good course, following our little guide, which will be available to you post-webinar. You'll be able to either download it or log on to our portal to access it. We're just going to do a quick inspection, and it's always important to do an inspection of the lens membrane. It's a sensitive part of the probe and important for electrical safety and infection control. We like to look at the casings to make sure there's no changes to the seals or joins that can affect fluid ingress, electrical safety and infection control. We like to look at the condition of the strain relief and the cable. It's always a good idea to run the cable through your hands because your hands are very sensitive and they will actually detect faults better than your eyes sometimes. And if everything's good, then actually what we can do is move on to how we would test this using a system. So right, moving on, we've got our little procedure, and the first thing it's going to ask us to do, that it's important that we're going to operate this transducer clean and dry in air. We don't want any gel on it left over from a scan, or even gel for the test process, because that's only going to make it harder for us to see any deficiency in the element performance. The next stage in our procedure is we're going to select an appropriate clinical preset. So we want it using something that's intended for function clinically. And on this machine, I've already selected a thyroid preset, which is quite typical for a high frequency linear probe like this. And the initial thing that we will see is the machine will bring on a series of settings, a depth and focus and frequency that the manufacturer believes is optimized to good starting place for thyroid examinations. However, what it won't particularly do is help us as engineers and biomed technicians in seeing defects. Now, with my trained eye and a lot of experience, I will look at this air reverberation pattern, and I will start to think that I might see some minor deviation there. But the average sonographer or user will be quickly moving from selecting the preset, having entered the patient's details or pulled them from the patient information system, to getting the patient in the correct position, ensuring they've got a clean probe with gel on it, and before they know it, they've not even noticed that that reverberation pattern might not look correct. And what we've got going on is a lot of processing and cleverness from the manufacturers that stops us seeing things. So we're going to try our best to defeat some of that and give us the best view. So the first thing we're going to do is select the highest fundamental frequency. So that means turning off harmonics. Harmonics being the feature of a machine where we transmit at a lower frequency to achieve the benefit of penetration, but we receive at a higher frequency, one of the harmonics, usually the first harmonic up, and that gives us the benefit of improved resolution. But what it does also do is it inadvertently masks some defects in the probe to the user's eyes. So what we're going to do is, on this machine, I'm going to select this control here. I'm just going to turn harmonics off, and that changes on the screen. And it'll also tell me up here that we've just moved to a general frequency setting. Now, I want the high frequency because that's going to help us see issues in the array. So it's going to maximize our ability to see that with our eyes. So I'm just going to use this control here and turn that to resolution, which I can see on the screen here and down in the control lower here. And that's the highest frequency up at towards 12 megahertz for this particular probe. The next thing we're going to do is just check we've got swept gain controls all the same. So we've got no additional processing going on there. And then we're going to turn off what we call advanced processing. So on this machine, I can see that we have both X-Res and Sono CT off. And as I turn the Sono CT off, which is the Philips compounding program, you will see a little bit of a change in the image. So there's the first one and there's the second one. And that's the most stark. I'm going to turn that on and off a few times. We start to see some dark vertical lines really appearing. Compounding is where we not only create a beam directly from the transducer, but we also do a couple of sweeps left and right with beam steering to allow us to see hidden anatomy, and then it composites that into a single frame. And that's great for the clinical image, great for the clinical user, not so great for us identifying defects. Okay, so the next step is for us to select a shallow depth where our air reverberation will cover between 30 and 50% of the depth of our image. So I'm just going to use the depth control here, and I'm just going to bring that down to about there. And what that allows us to do is, by selecting a shallow depth, we are inadvertently reducing the aperture size on the transducer, so it's using less elements to create each beam. That's going to make it easier for our eyes to detect faults, and when we use the test tool, easier for us to see the changes in any ringback pattern. The next thing we want to do is select a single focus, and we can see our focus caret just here, and we're going to move that using this same control. Let's just move that up to the top once again by using delay lines in the beam processing and beam forming. We're going to create an even narrower aperture, which helps us identify things. And I think we can agree, even with just those settings, we can see much more change in this air reverberation pattern now than we did initially. So what we now want to do is just adjust our gain to avoid saturation in the lower part of the image. So I'm just going to use the gain control here. So this is very saturated, lots of noise. And we're just going to bring that back until we lose the noise. Now, ideally, you do this in a darkened room so your eyes can maximize the information coming from the screen. But for today's purpose, I'm just going to demonstrate it like this. And what we can now see is what we call our air reverberation pattern. And we're just going to pause, and I'm just going to freeze out. And we're just going to look at that a moment. And what that's going to tell us is, I think we can see some dark vertical streaks, which are indicating some kind of dropout, which could be down to something going on with the lens or the elements in the array or the cabling, or even a defect with the connector. So sometimes just manipulating the connector can be a good idea to just check. We also see what I think is a bit of a fuzzy area here. And what we're looking for is non-uniformity. And I think we can say that's non-uniform in many areas. Unfreezing the image, it's always a good idea just to manipulate the cable near the strain relief. And we don't want to be too aggressive. So I generally just hold the strain there and we just move that around. And I don't know whether you can notice here, we're seeing flashing within the image. And we're seeing a little, there we go. That's coincident with micro fractures in the micro coax cables. And what you're doing there is we're just seeing the presence of wear and tear or not care with the probe, because obviously there's a lot of bending mechanism goes on as they put it on the patient there. So it's quite common that we will see fractures there. If the cable's been run over anywhere on its length when we've inspected it, so if it's been run over a wheel here, you might find that just manipulating the cable there might also show things coming on and off. These are beginnings of indicators that this probe's not very fit for purpose. Then the next thing we can do is test what we think we're seeing with the air reverb pattern by getting some kind of a ringback using the test tool. So those of you that have registered for a website, hopefully you've received your postcard with your test tool on. And if you've only registered for today's first on, then we'll be getting one of those over to you with the test protocol quite shortly. So the way to do the next stage is make sure you're unfrozen. We've optimized our settings. I'm going to just apply a very small film of water on my finger to the lens, just to allow a little bit of reduce the friction. And what we're going to do is our specialist test tool held this way up. So we've got the little gap at the bottom to make a small metal interface. We're going to hold it at 45 degrees and we're going to gently sweep along, and hopefully you can see on the screen of the ultrasound machine a comet tail in the same position I've got this on the array. And as we sweep across, we look for flashing on and off as we go over the dark areas. And that is classic kind of dropping out of the signal. This center area is quite good, so we don't really lose the signal. And then over here, the signal gets a bit mushy. And then we go over here and we got some more flashing. So that's typically how you test the probe. So it's a firm pressure, but not too firm to damage the lens material. And just on the edge, because we want the smallest surface area to be in contact with the face of the array. So we're only blocking out the transmit signal from the smallest amount of elements at one time. So what I've effectively done there is decided that I've got an area of weak in performance and lots of areas of either permanent lack of performance or intermittent performance because of the cable. Now, our little guide, which we said will be available to you, gives you indications on the back how to look at things for defects for visual inspection, but also how to read and interpret some of the information you may see. And whilst I'm using a linear probe today, a curvilinear works in exactly the same way because of the beamforming. And we've designed a little red, amber, green. So red being take action immediately and do something because there's defects with the probe. Green's everything's okay. And amber means we might need to do a little bit more. But what I hope we've been able to demonstrate to you, that with a simple test that takes a few minutes, a clean protocol that allows us to optimize the system settings, that we can effectively see the same results as we'd get from a FirstCall. So over here, this area here is this area here, and we can see we've lost capacitance. And those that have seen the other webinar will understand how to read these and differentiate between cable breaks or element dropout. And over here, you'll see many coincident lines. So effectively what we're seeing in the field or first line environment, even without a FirstCall, is our ability to identify the same defects. And importantly, what that allows us to do is identify all gross defects, which are the kind of defects that we would really want to take action on immediately. So they're the kind of things that would definitely affect either clinical imaging, which the users may not see easily, but it may create artifacts in their image. But absolutely, any significant level of dropout of elements will interfere with Doppler measurements. And there are very few measurements, examinations, these days that don't involve some kind of Doppler flow measurement of blood. Just to give you an indication of one of the reasons why we optimize, I'm just going to reset this preset back to its original settings, which is where we started. And you can see the faults almost disappear. And I'm just going to put my little bit of water onto my lens again. I'm going to get my test tool. And even though I've seen hundreds of probes a week and it's coming through our business, I'm going to use this. And I don't think I can genuinely determine what's good and bad looking at these results. I wish I could, I just can't. Now, you might also notice that there's 3 streaks almost making a triangle, and that's the effect of the compounding that we talked about. And it kind of demonstrates our compounding as a series of beams and then overlay to make a single image. So hopefully you found that interesting. And what we're going to do is open up the floor to some questions. So I'm going to bring myself back onto the camera, and then we'll bring Jen back online, and hopefully we can answer any questions that you've got.
Yes, so thank you, Darren. If anyone has any questions, you can please put them in the chat panel now. And like Darren said, your test tool will be in the mail and you will be receiving that shortly. And if you have any friends that would like one as well, they just simply need to fill out the webinar registration form, and they will also get one free of charge. So while we wait for some questions, we had some submitted beforehand by people who could not be on the webinar, but will be watching the recording of it. And we'll start with one of those. One of the questions, Darren, is, can you test a phased array the same way?
You can test a phase array, Jen, by optimizing the system settings and using the test tool. What you can't do is meaningfully get something from the reverb pattern in air alone. Now, we're going to do another webinar next week because the optimization of the settings is a little bit different. And we also have to use the M mode or motion mode feature of the machine. But what we will be able to demonstrate next week is that with a phased array and the test tool and a slightly revised procedure, we can absolutely demonstrate dropout down to a single element, which, you know, like I've said, single element dropout starts to affect Doppler measurements quite soon. So it's important that we can identify that. Okay.
And another question was, how can we find out more about your repair capabilities? And I can go ahead and answer that. We repair all major OEM makes and models. So we offer free loaners as well, quick evaluations. So if you have any requests, you can just please email me directly, and we can answer any questions and get that loaner out to you and get the eval and your repair complete. And another one is, how can we test a matrix array?
So there is ways to optimize the settings and do some advanced protocols, and it's a mixture of the linear and the phased array depending on the configuration. I think, Jen, we're hoping to run a specialist webinar and workshop for that later in the year. It's a lot more advanced than either of these initial webinars that we're doing, but absolutely in the field we have developed abilities to see phased arrays and matrix arrays, and I think hopefully in the near future there will be our research around how we've tested multi-row matrix arrays will be published as well, so that'll underpin what we're going to talk about later in the year.
Okay, great. So everybody can look out for that next webinar is coming up. So just keep an eye out on LinkedIn and so forth, and emails for further webinars, as Darren said. I hope everyone did enjoy today's session. Our next session will be 2:30 Thursday, April 22nd. So same time next week. And again, if you have any colleagues that would like to join us, please point them to our website, multi-medix.com, and they can fill out registration and also get the free test tool. So that's it for now, and hopefully we'll see everybody on the next webinar, and we hope everybody enjoyed it, and have a great day.
Have a great day, everybody. Thank you, Jen. Thanks, everybody.
Thank you.